Great. Anybody want me to do any more of this kind of vector stuff? Let's look at the various top. No, not here. Just to double check. Let's see where it went. Right. So we got component vectors and vector addition, components of vectors, unit vectors. What else? Products of vectors. Oh yeah, for sure. Always ruler. Always, you know, when you're anytime you're using vectors, right, Raymond? Oops, oopsie. I don't want this. And a protractor is a great idea, right? Anytime with vectors. So there's the, let's see, vector addition, components, units, products. Anybody have any interest in those? There's no cross product, just the dot product. We'll use cross product a little later. I know it's in chapter 1, and maybe there's a problem with a cross product, but it won't be on the exam. Okay, so I could go on to chapter 2 problems. Okay, I got one, yes. Okay, let's see. I want to then, okay, I can do that. Yeah, I mean, again, you guys are all seeming pretty good in math. Cancel this. And all assignments. And chapter 2. And edit assignment. And that's chapter 2. It's so weird. What is going on here? End of chapter. Oh, good. That's what I want. Okay. Displacement. Well, let's look at the topics. Instantaneous, average, motion with constant acceleration, free fall, velocity and position. And in fact, now I have a textbook I can look at. It's easier for me to look at the textbook. Where did it go? Chapter 2. Anybody have a particular one they want? It could be a homework problem. It's overdue now. Velocity and position by integration. Should I just pick some randomly difficult one? See if I can screw it up. Earthquake analysis. And that claims to be a hard one, huh? Produce several types. The most well-known are that's the longitudinal waves. Like they're like sound waves. They travel really quickly. And then the S waves come later, and those are the ones that are like sine waves that knock the buildings down. Well, let's give that one a try. Let's see, have I done, yes, I have. Oops. Copy. Ooh. Come on. So this is one of those ones where we a drawing is a good thing. And let's see. So we have the earthquake place. And we have the point of observation, P observation. And we have some kind of distance x, and we'll just call this the positive direction. And let's see, so we want to know what is the distance. And so we have velocity p equals 6.5 times 10 to the third meters per second. Velocity s equals 3.5 times 10 to the third meters per second. There's no acceleration, so that's good. All right. So, excuse me. So, all I know is that, and there's a delta t arrival equal to 33 seconds. So I think, so we know that delta t arrival. I have a couple of ideas how to do this. Well, they both are going to go the distance x. They both have an x sub 0 equal to 0. So that is going to be velocity of a p wave times the time of a p wave. And it's also going to be a velocity of s wave times the time of an s wave. And we know that the difference between those two times, when that equals that, is 33. There's a delta t. So what could we do? Well, see, right now I'm not exactly sure, so I'm just going to scratch some stuff out. I mean, part of me says equate the two of them. And what could we do if we equated the two? We don't have a ratio of them. We have a difference between them. So if we had some ratio between them, so, oh, wait a minute. Aha. I think I have it. Which one is fat? So TS, the time of S. So that one's going to be long. That's going to take longer. That's going to get there quickly. So T of P actually equals T of S minus 33, huh? So what would that do for us? Well, that doesn't only eliminates. We have two unknowns, so that isn't helping us. Haha. So what do we? Yeah, we have two unknowns, three unknowns, but we have a relationship between them two. So now we can make it two unknowns. Can we make two equations? Oh well, I thought I could figure this one out. Let me glance at the answer. I mean, I would prefer to my way of doing this would be I would stare at it for hours, and but we don't have that kind of time. Crap. Unless one of you thinks of something, you're perfectly. It's perfectly all right to show me up. I hate doing this. Maybe I won't look at it. I'll just get it ready to look at. There we go. Uh, yeah. Oh, of course. Huh. That was crossing my mind. Damn it. Of course. So we have this relationship, and so we get T of P equals X over V of P. And this only works because they both equal X. And T of S equals X over, V of S. So, right. And I wouldn't even set it up this way. I would just say that TS minus TP equals 33, right? So TS is X over VS minus X over VP equals 33. So that's nice. This is easily factorable. So it's X 1 over VS minus 1 over VP. And then, so we just divide by that. Oh, wow. That became pretty trivial, huh? Well, we should test it out, right? Because you got to keep these inverted. So it's not trivial to type this into the calculators. So why don't you guys have a crack at that one, so we can all get an answer, and we can compare our answers. But let's see. I like that one. I'm just going to make some room. Maybe. Well, there we go. So let's see. 1 over 6.5. Where's the inverse key? Yep. So 1 over, oops. Come on. 1 over VP equals 0.154. 1 over VS 0.286. Okay. 0.154 subtract. So it's 33 over 0.132, I think. All right. So I got 251 kilometers. It's pretty cool. All right. Anybody get the same thing? Well, most importantly, did anybody get something different? I can wait. Ooh, hopefully that's familiar to some of you. Save as. Oh, how did that get there? Because I probably hit the save key. Lectures 2100. Anybody get a different answer than me? This this is review. Chapters 1, 2, 3, huh? Nobody? Anybody get the same answer? Ooh. Is this thing on? Guys all snoring away out there? Oh, good. Thank you, Raymond. Beginning to feel like I was all alone. Okay. Calculus. Well, this is one that's only got one dot. So this one might be on an exam. Copy. Let's see. All right. Excuse me. Come on. What the heck's going on? Yeah, this is a nice one. Excuse me. My phone is beeping at me. Why is my phone beeping at me? Let's see. Oh, missing person. I get text alerts from the local police. All right. Let's make this a little bit easier to read. Why is this lagging so much? I wonder. There we go. Of what is the initial? Come on. All right. This is annoying me. Okay, so we better double check the formulas here. Oh, great. Just what we need, another feature. I love features. Okay, so y equals b minus ct plus d t squared. Okay, lunar lander is descending until the lander, its height above is giving me, okay, so its initial height equals 800 meters. B is C is 60 meters per second. And so this is the negative direction. And see something here. No, just C. Wait a minute. C and D equals 1.05 meters per second squared. And that is the rocket thruster. Okay. See, because it's falling, and I guess the initial height. So that implies that so let's see. It could be that y sub 0 equals 800 meters. Yeah, I think so. And then the ground is 0 meters. I don't know if you call it the ground on the moon. 800 meters. So you see, we can infer things, right? We're inferring that because they give us a positive initial velocity at 60 meters per second, and they're also telling us that it's falling at 60 meters per second. And then we see there's a negative sign in front of it. So that's telling us that the downward direction is negative. And it's sort of implied. So what is the initial velocity? Wait a minute. It gave us the initial velocity. That look, not exactly. Got to be careful, right? This is, so maybe there's what? It says until it reaches the surface. So we can't, strictly speaking, I guess, say that C is the initial velocity. I don't quite understand why not myself. But we might as well just make sure, huh? Okay. So I see, that's a trick, right? Because it said initial velocity. So they told us initial speed, I bet. Did it say the word speed? No, it just said what C is. Okay, all right, I see. But anyway, let's just be careful for a minute. Let's first we do numbers. Negative C plus 2 times dt, huh? So V, and we could say V of t. So V of 0 seconds, sorry, equals negative C. So that means that the initial velocity is equal to negative 60 meters per second. Okay, all right. What is the velocity of the lander just before it reaches the lunar surface? Okay, so that means that we need to know t at the time of contact, or when y equals 0. Now, let's think about this for a minute. So velocity, well, again, is equal to minus c plus 2 times d times t. So this thing over enough time would start going up again as long as it had enough earth underneath of it. So I'm trying to remember that. It really bugs me that I don't remember my calculus anymore. Because it seems to me that you could, let's see, take something about zeros and second derivatives. So the second derivative of this, oh well, anyways, so that means that the way to do this is to take this equation. So there doesn't seem to be any calculus in here, other than if we got our if we learned the quadratic equation in calculus class. So this is y equal to 0. So then we get, how do we factor this thing? Well, we can just plug it into the quadratic equation, right? 28 seconds plus or minus 7 point, it reaches the surface. Okay. So this is a quadratic. I don't think there's any way around it. Quadratic. Right? Let me think about this. So you got, right? So you can just simply plug this in, and then for the quadratic equation, this becomes A, this becomes B, and that becomes C, I think. We should make sure. Quadratic. Oh, I should have put down a quadratic. Oh, here it is. Oh, right there. Shit. Right. So I was right, huh? Yeah, A, B, C. No, I got it backwards, right? Sorry. All right. We all like, why don't we do it? Red. A, B, C. There is the quadratic. I want to do this. I haven't done one of these in a while. So T equals minus B plus minus B squared minus 4AC. That's a square root over 2A. So A equals 1.05. And I wonder if the units matter. That's a funny thing. It has to, right? This will be an interesting thing to see if the units come out right. C is 60 meters per second. Am I right? No. B is 60 meters per second. And A, B, C is 8. Oh boy. 800, right? You guys check me out here. Equals 800 meters. Right? Yeah. A is the acceleration, B is the speed, and C is where is Y initial. I don't want that to say Y0. So we got minus 60 meters per second plus minus 60 meters per second squared minus 4 times A, 1.05 meters per second squared. Right? A is the 1 times the x squared, right? And times C, which is 800 meters. So you got meters squared per second squared and meters squared per second squared. Well, that's good. So 3,600 minus 3,200 times 1.05. Oh my God. What a lame thing to put. Yeah. 1.05. And that's square rooted. So they'll both be meters per second. And then 2 times A. Oh, that's a bummer. Oh, no, that's right. So 1.05 meters per second squared. So then we'll end up with seconds. Oh, so it does. Look at that. That's amazing. Who knew? Okay. 3,600. Enter. 3,200. Enter. 1.05 times. Subtract. I got 240. Square root 15.5. So minus 60 plus or minus 15.5 divided by 2.10. Okay. 60 enter 2.1 divide. So it's minus 28.6 plus minus. I must have made a sign mistake. Oh, right. No, C is, yeah, I did make a sign mistake because we have to make it, since there's the minus sign there, so B is a minus number. Okay. We square it there, so it didn't make any difference. But at the end of the day, that's a plus. That's a plus. Sweet. Okay. 7.75. I suppose if we made it to, so we, one of the two will give us, so let's see, 21. What's the final answer? 7 point, now they got 7.38. All right, let me do it again. 15.5 0.5, enter to divide. Oh, well. So then it's just a matter of plugging the two in and seeing which one gets you y equals 0. And they claim that it's 21. It's the subtraction, 21 point something. It's actually 20.9 something. Okay. All right. I mean, I'm sorry. It seems like I'm being pretty boring here, but I guess I'm not picking out good questions.